Welcome to Chapter 11, Section 10, entitled Rotations. A rotation occurs when a figure is rotated around a point. So, this triangle will be rotated around a certain point. Alright, to set up this rotation, for the most part you're going to be rotating around the origin. Now, in this example it says to graph first x, y, and z. Then graph the figure and its image after a clockwise rotation. So, step number 1 was to graph the original. Step number 2 is to sketch segment Z0, so ZO, connecting point Z to the origin. Sketch another segment Z prime O so that the angle between them measures 90 degrees. Okay. Now you can use a protractor if you want, but you also know, all of you know, that 90 degrees is pretty much a right angle. So clockwise rotation. Okay. If here is a clock, this is clockwise. This would be counter clockwise. So that determines which way you draw your line. We're going clockwise, so we need to do a 90-degree angle clockwise and come straight up through there to here. Okay? Now, once you have all that, you do similar draw. So now we have a point right here. Pretty close right there. Then we're going to do the same thing with this. Draw a line segment, and then the identical line segment. Right here. We do the same thing then for x. Right there. Right angle. All right here. And you draw your triangle. There you go. And that's pretty similar. That means my coordinates are, for x, 1, 2, 3, 4, 5, -2. Y is 1, 2, 3, 4, 5, 6, 7. And z I have as 2, 2. The nice part about this is really we're rotating it, but as long as we do the process right, our points might be estimated. So triangle XYZ has these points. So remember, step number 1, graph the original triangle. So x is at 2, 4. Let's use red. 1, 2, 1, 2, 3, 4, 2, 4. Y is at 0, 1, 2, 3, 4, 5, 6, 7. And z is -2, 2. Ah, okay. Oh, I don't want to use green, I want to use blue. Okay, so you may think, wait, this is the exact same problem we just did, right? Except that for this one, we're dealing with a counterclockwise rotation. So counterclockwise means we go to the left. So let's start with the blue point. Draw the segment to the origin, and then a identical segment 90 degrees. So we're looking at about right there. Red point, there, 90 degrees, about right here. This one here, 7, right here. So now I have all the points I need. They're estimated, but hopefully you can see that even our estimated points, the triangle still looks very similar, and we have now rotated it 90 degrees. All right, a figure has rotational symmetry if the figure can be rotated about its center by a certain number of degrees and still look like the original. So this rotational symmetry can work with a lot of things. Let's see if I got some shapes here that have it. Okay, this right here, this star has rotational symmetry because this point right here can be rotated to this point, which can be rotated to this point, rotated to this point, rotated to this point, rotated to this point again. And every time that rotation happens, this rotates here, and so on. So you can rotate it around a certain number of degrees, and it still looks like the original. The angle of rotation is the degree measure of the angle through which the measure is rotated. So take a look. This point here got rotated to here. So let's come up with an origin. What you'll end up with is, you'll end up with going from here to there, there to there. That is your rotational symmetry, your degrees, whatever this, oops. Whatever that is. So determine whether the letter A has rotational symmetry. Write yes or no. If yes, name the angle of rotation. All right, so looking at this point right here, or this point here, or any of the points on here, pick a point and see if you can rotate it so that it'll line up on any of those original points to make it the same. Since the letter cannot be rotated and still look like the original, the letter does not have rotational symmetry. Let's think about the H. All right, let's pick this point right here. All right, so here's this point right here. And if we rotate this point, you'll see that when it hits right there, it looks exactly like it did before. We rotate it up again, it looks exactly like it did before. So the answer to this is, does it? Yes, it has rotational symmetry. The question now is, what is that rotation? Well, originally, in the first example, we had an origin in which we drew a line segment from there to the origin, and then a new line segment from the origin to the new point. And what you've now drawn is a straight line. If it's a straight line, the rotational symmetry is 180 degrees. So let's add that in there. If your line is straight, that equals 180 degrees. If your line is a right angle, you have 90 degrees. If it is on top of itself, then that means no rotational symmetry. And I think these are the main ones you're going to be dealing with today. You might have a 45-degree rotation, which looks like would be something like that. You can estimate those rotations. All right, so I'm going to add an extra piece to here. Let's take a look at some shapes. Here's another shape. This is not part of your notes, but you should pay attention to it. All right, let's check to see if it has rotational symmetry. This point here could match up with this point here. And if it does, you draw a straight line to there, origin, the center of the shape to the point, center of the shape to the point again, and estimate the angle. All right, I would estimate this as a 90-degree rotation. Okay? Now, you could also go from this point to this point. That would be a straight line. So it has 90. It has 180 degrees. It also, if we went all the way to there, that's 90, 90, 90. It also has 270-degree rotation. All right. Now, you need to make sure you watch this video and understand what I said and follow through the examples so that when you go to page 617, you can do the CYUs located on problem page 617, numbers 1 to 6. And then in class, you'll be working on these problems. Good luck.